ladies and gentlemen.
Welcome everyone, let's talk polynomials. So a polynomial is a string of different monomial terms containing constants and variables. So a monomial is like x squared or 3x or 5. All of those are little terms and we separate them with addition and or subtraction. So a term is a combination through multiplication and addition, and we separate them with addition and subtraction. Multiple terms makes a polynomial. Fun stuff. So standard form is when we write these as decreasing exponents. So if I have x cubed plus 5x squared, that's okay. But if I have x to the fourth minus 5x to the fifth, that's not in standard form because the powers aren't descending. And just so we are all clear, any number, so a number like 1 or 5, has an x to the 0 power attached to it because any number to the 0 power is just 1. So the constant is what we would call that. The term without the x is always the last one. So let's rewrite a polynomial, specifically 4x minus 2x cubed minus 5 plus 9x squared in standard form. So we are going to take each term with the operator in front of it. And if it doesn't have an operator in front of it, it is positive. And if it has a negative in front, it's negative. And minuses just mean negative. So we're going to take this one here because it has the highest exponent. And we have negative 2x cubed. Next one to be this positive 9x squared. Then we have this positive 4x. And we have this negative 5. So that would be in standard form. Again, if it's subtraction, you just consider that term to be negative. Not too bad. When we add or subtract polynomials, we want to make sure that we are only adding like terms to each other. What is a like term? Well, like term is where we have the exact same variables in the same amount. What do I mean by that? I mean that x squared and 5x squared, like terms, same variable, x, in the same amount, we have two of them. But if I have 3xy plus 3x squared y, even though the y's are the exact same power, they both have a power of 1, the x's are not the same. So those are not like terms. But if I raise this x to be squared, these can now combine because I have the same variables in the same amount. So with all that being said, let's subtract these. So what I like to do, especially if I'm not certain, is I like to distribute. So I'm going to distribute this subtraction to all of these terms. So this one can stay exactly the same, 3x squared minus 4x plus 8. And the other reason these parentheses exist is for this subtraction. So when I distribute, I don't need them anymore. So I have minus 2x squared. Nope, not plus 6, minus 6x plus 5. And remember, negative times a negative makes a positive. Now we're going to group together our like terms. We have 3x squared, negative 2x squared. Those are like terms. And 3 minus 2 is just 1, or x squared, not cubed, Mr. Whaley. Next up would be the x's. So I have a negative 4x and a negative 6x. Negative 4 minus 6 is going further negative, which means we have minus 10x. And the last but not least is we have our constants. We have 8 and 5, both positive, so we have a plus 13. And that would be simplified. Now this again is why I like to distribute, is sometimes we might have coefficients or we're multiplying by multiple pieces. So I like to do everything kind of methodically, if you will. You don't have to do it methodically like I do, but it definitely helps. So we're going to distribute this 2 to all of the terms here. So we get 8x to the 5th. Notice that the power is not changing here. 2 times negative 3 would be negative 6x cubed. 2 times 8 would be plus 16x. And then over here, 5 times x cubed would be a positive 5x cubed. 5 times negative 7x would be a negative 35x. And then 5 times 1 is just 5. So like in the previous problem, we're going to combine like terms. I notice that this 8x to the 5th does not have a buddy, so it stands alone. Sorry if that's a little hard to see. We've used that one. Now my cubes, I have negative 6x cubed and a positive 5x cubed, so we have a minus 1x cubed, or just minus x cubed. Next up, I have my x's. I have a positive 16x and a negative 35x. And sometimes these two-digit numbers, especially when we're subtracting and we're going to end up with a negative number, can be a little bit difficult. But keep in mind that 16 is, it's the absolute value of 16 is less than the absolute value of negative 35. So what I can do is I can just say I'm going to do 35 take away 16, and then whatever number I get as a result, I'm just going to make that negative. So if I do it this way, it helps me out a little bit. And what I can do is I can shift these numbers up a little bit. I can make this 39 by adding 4. So if I add 4, I get 39, which means I have to subtract 4 more than I did before. And that gives me 20. Subtracting those, very easy to see that we're going to end up with a 19. That would be negative. So minus 19x. And then we just have this plus 5 on the end. And that is simplifying that one. All right, so next up, we are multiplying. So if you multiply a polynomial and a polynomial together, you have to be kind of careful. Now this one's simple. We have a binomial and a binomial, which means two pieces. And that one's relatively easy. There's a lot of different methods you might have heard of. There's the area model, there's FOIL, and then there's one that I like the best for me, which is cutting into pieces. So what I do is I take the smaller of the two. This one, it really doesn't matter. So I'm going to take the first one, and I'm going to cut each of the monomials apart. Now I'm cutting it so that if there's a minus, I know that the minus goes with the 3, that this 3 is negative. And I'm going to rewrite these two separately. So 2x and then minus 3. And then each of those is going to get the second polynomial. X plus 4, x plus 4. And now this problem looks very, very similar to the one we just did. So if I distribute this 2x to both terms, I end up with 2x times x. Now this is where the powers change. If you have an x times an x, remember that's going to increment the exponent by 1. So 2x squared, and then 2x times 4 would be plus 8x. Then we have negative 3 times x, which would be minus 3x. And then negative 3 times 4, which would be minus 12. Combine like terms here. We have two terms with x. We'd end up with 2x squared plus 5x minus 12. So not too bad. Why I like the cutting is if I have really long strings of polynomials where I have a polynomial that has like 5 terms multiplied by a polynomial with 5 terms, if you use the area model for that, you're making 25 boxes. And you can't FOIL that one. So it makes life a little bit easier and it's more generally applicable. Now, factoring is something that we're going to talk about a little bit more in detail in another video. But there are 3 common factoring techniques, and there's one that is super useful, and that is the difference of squares. If I ever have a square minus another square, that factors to be adding the square roots together and then subtracting the square roots together and adding those. what do I mean by that? Like if I have 16 minus 9, that is the same thing as 4 plus 3 times 4 minus 3, which can actually make the simplification a little bit easier, especially if you have really big squares, to have 7 times 1, which is just 7. So that is an application thereof. Difference of squares I know comes up a lot in calculus practice and sometimes in pre-calculus, so very nice to have under your tool belt. If I have the same idea, but I have a plus y squared instead of a minus y squared, and what's in the middle is double the square roots of those, then I have x plus y. And if the middle term is negative, then I have minus 2y. All right, next problem. We have if m times n is 3 and m minus 3n is equal to 17, what is the value of m squared n minus 3m n squared? Now this seems like an impossible task, but we can actually simplify what's going on here by factoring out some variables, factoring out some things that are in common with both. So factoring is the process of undoing distribution. So instead of multiplying every term by the same thing, we're going to essentially take it out. We're going to divide by it. So the first thing I'm going to do is I'm going to rewrite this. So we have m squared n minus 3m n squared. I notice that they both have an m in common. So what I can do is I can factor that m out. Now, factoring, again, is like division. So if I factor it out and it goes away, it doesn't turn into a 0, it turns into a 1. So factoring out an m gives me mn minus 3n squared. So that m just turns into a 1. 1 times negative 3n squared is negative 3n squared. I notice they both have an n in common, so factoring that out gives me mn, which is m minus 3n. So now we can see, oh, I have a value for this. I have a value for this. This is just 3. This is just 17. 3 times 17, that's a tricky one. Well, 3 times 10 is 30. 3 times 7 is 21. So 3 times 17 is 51. Not too bad. Now, some of you might be asking, can I factor out the mn in the first step? Do I have to factor out one at a time? And the answer is you can factor out as much as you can as early as you want to. As long as they have them in common, you can factor it out. So you don't have to do it one little piece at a time. You can take the whole kit and caboodle with you if you need to. Here we have x plus y is 11, and x squared minus y squared is 55. What is x minus y? Now, this might be a little easy to figure out, but we're essentially going to factor. So we have x squared minus y squared is equal to 55. Well, x squared minus y squared is the difference of squares. That is x plus y times x minus y. The order doesn't matter there. Is equal to 55. Well, x plus y is 11, so this is 11 times x minus y is equal to 55. And some of you are going to be like, I'm going to distribute that 11. Don't. And the reason why you don't is because we don't care what x is individually. We don't care what y is individually. We care about what x minus y is. And I already have x minus y. The problem is the 11. Distributing it just makes the problem compound on itself. If I divide instead, I get x minus y. Ooh, foreshadowing. X minus y is 5. And that's my answer. So don't go gung-ho of, can I simplify this as much as possible? Because sometimes it's set up in such a way that the structure is very beneficial the way it is and not how you could manipulate it. So try to think about what your end game is when you're solving these types of problems. The last one is, let's factor this completely. So I see 20a squared minus 5b squared. I notice that 20 is a multiple of 5, so I can factor out a 5 to start. That leaves me with 4a squared minus b squared. Now 4 is a square, a squared is a square, and b squared is a square, and I'm subtracting. So this is actually the difference of squares, where the a in our difference of squares, the x we had up at the top there, so let's use that instead, where the x is 2a and the y is b, because 2a squared is 4a squared, parentheses, and then b squared is b. So this just turns into 5 2a plus b, and then 2a minus b. We don't get an extra 5. Very important. We do not get an extra 5. This 5 is from over here. This breaks down into these two factors. If you add another 5 in there, you end up with an answer that is 5 times more than what you started with. So be careful there as well. I hope that wasn't too bad. If you have any questions, please let me know. Otherwise, I'll see you in the next video.